Welcome back for practice 40. This one is talking about line plots. If you haven't watched the instructional video, you need to do that first because that will help you understand what a line plot is, how to construct one, how to read one. It's just good information. So on this one, I'm assuming that you know how to read a line plot. This is page 38 of your workbook. And let's take a look at this first one. It says to use the line plot for items 1 through 4. So let's study this line plot that shows the amount of water in various vases at Sean's flower shop. So to construct this line plot, I could have walked into Sean's flower shop and measured the water in each vase. And let me just review with you what this is saying to us. If you look at this first column, notice that this is cups along the bottom. So in this first column, it says that 3 vases have 1 cup of water. Each X represents a vase. 3 vases have 1 cup of water. Three vases have 1 1/4 cups of water. Two vases have 1 1/2 cups. 2 vases or vases have 1 3/4. And 2 vases have 2 whole cups. Now, if you're taking a test, I do not want you to sit and do this. But we're learning about line plots. So take the time to make sure you know what it's saying. What if they ask me how many vases are in the shop? How would I find that? You would count the X's. You have 3, 6, 7, 8, 9, 10, 11, 12. So we're looking at 12 vases in total and how much water is in each one. So make sure that you know how to read the graph. Here's your main idea, and you want to be sure that you understand the scale, what the scale is talking about. Okay? All right, let's try the questions. The vases with fewer than 1 1/2 cups of water hold a single flower. How many total cups of water are in those vases? Now I'm going to do something. I want you to just close your eyes for a second. Just don't pay any attention to this. Close your eyes. You're not watching this. Okay. There, let me bring it back. Okay, you can open your eyes now. I just made a picture of this graph so I can bring it down here, and I wanted the stuff off of it, so that's all I did. I just made a picture of the graph. The vases with fewer than 1 1/2 cups, so let's mark those. You don't count the 1 1/2s, you take the 1 1/4 and the 1s. Here's 1 1/2, and you're going less than that. You're going below that. These hold a single flower. How many total cups of water are in those vases? Well, 3 of the vases, those are the X's, have 1 cup of water. and 3 of the vases have 1 1/4 cups of water. So we need to do some simplifying here. 3 times 1, that's 3. So this part is 3 cups. And that means plus 3 times 1 1/4. Use your calculator for this. If you're using the Casio, you just type it in as a fraction. That calculator is awesome. If you're not using a calculator with a fraction key, you can do 1.25 and get the same thing. So this is 3 3/4 cups of water. And then don't forget to add those together to get 6 3/4. So the answer that you want here is D. 6 3/4 cups of water. Okay, number 2. Let me pull the graph in again. How many vases contain more than 1 1/2 cups of water? So that's going to be these and these. 4 vases. You just count your X's that are more than 1 1/2 cups. Number 2 is A. Number 3. The vases with more than 1 1/2 cups of water hold 3 flowers. How many total cups of water are in these vases? So let's take a look. Shrink that down just a hair. We are interested in those with more than 1 1/2 cups. So we're interested in these and these. And I have 2 vases that have 1 3/4. And then 2 vases that have 2 cups of water. So again, on your calculator, if you can't do fractions, do 2 times 1.75, and that's 3.5 or 3 1/2. Let me do it fraction way. Plus 4 is 7 1/2 cups of water. And that is number 3, C. We've already answered this one. How many vases, assuming this is all of them, does Sean's flower shop have in all? So you just add them up. Count the X's, basically, is all you're doing, because each X represents a vase. And there are 12 of them. And that is reading a line plot. Number 5. Pierce records the number of hours he spends cooking each day for 2 weeks. And these are the times in hours. Which line plot represents the data? So in order to do this one, I'm going to use what's called a tally table. And I'll explain how that works. So let's draw a table. And in it, I'm going to always put a header row. And I'm going to make this look like this. And let me go ahead and put one row there. So this first row is going to be the number of hours. And then this is going to be called the frequency. This is where the tally marks go. Sometimes this is called a frequency table. Okay, on the first day that he recorded time, Pierce spent 1 1/4 hours cooking. So I'm going to put 1 1/4 down, and I'm going to put 1 tally mark for that entry. He entered that 1 time. And I'm going to highlight them as I use them. So that one's done. Then 1 1/2. That's going to be the second entry. So on that next day, he cooked a little longer. And that tally mark represents 1 time that I see that. Then I see a whole hour, just 1 hour for this next entry. And then I see a 4th. I may have to add some room on my table. I see 1/4 down there. And then a 1/2. Is there. And then 3/4. I see there. And then I see 3/4 again. So I don't make a new entry, I just put another tally mark. And then I see a 1/2. And then a 3/4. And then another 1/2. And then another 1/4. And then a 1 1/2. And then a 1/4 and a 3/4. Now, I'm going to stop right here and make sure that I got all of them in there. And the way you do that, we're going to add up. Here's 1. This one has 2 entries. 1, 3, 3, and 4. So I want you to count those tick marks. 4 plus 6 is 10, plus 4 more is 14. And that should match the 14 days that he has. Make sure you included them all, because if you've missed one, your chart will not come out right. Okay, so now we need to figure out which one of these graphs matches our tally table. So the way I'm going to do it, I'm going to focus on this 3/4. Whichever answer I choose needs to have 4 X's with the 3/4. Each of those tick marks, those tally marks, represents the X's. So let's focus right here. A only has 1 X for the 3/4. So A is not it. B has 2 X's with the 3/4. That's not it. C has 4 X's with the 3/4. That could be it. But so does D. Okay, so the 3/4 fit on those. Let's see. Is it C or is it D? Let me do it this way. I'm going to pull a copy of this right down here if I can. Yes, here we go. So let's zoom in. Let's see which one fits. According to my table, whoa, let's bring him down here. According to my table, the 1/4 entry, which is right here, is supposed to have 3 X's. And C doesn't match. 1/4 only has 2 X's. So it's not C. The answer you want that fits this table we made is D. And I think I'm making a bigger deal out of this than it needs to be. But I know it's kind of confusing. Until you get used to these, it's a little bit of a tricky thing. But D is the table that matches the table we made. Okay, that's a good question. I like these. They're just not easy. Okay, number 6. It says to use the line plot for items 6 through 8. The line plot shows the distance Margie jogs each day for 2 weeks. And I'll tell you what, this seemed to work well before, if you'll bear with me. I'm just going to take a picture of that so I can keep using it. How many days does Margie jog fewer than 1 7/8 miles? Now, I want to call your attention to something. This book is very nice to us. They put these in order from smallest to largest. That is not always the case. So just make sure that your numbers are written in order from smallest to largest before you start making decisions. But this is showing me the distance in the miles, and these X's represent days. So on 4 days, she did 1 3/8 miles. The question is, how many days does Margie jog fewer than 1 7/8? So I'm going to make my line right here at 1 7/8. Let's actually do it with a solid line. Here's 1 7/8. I want to go fewer than that. So we're looking at this interval on the graph, which would be all of these X's. Count the X's. 8, 10, 12, 13. So C is the answer on this one. Fewer than 1 7/8. Margie jogs the same route every Saturday and a different route every Sunday. Both of these routes are shorter than 1 3/8 miles. So make your line shorter than 1 3/8. It would have to be right here. And so the interval is down here that you're looking at. How far does Margie run in 2 weekends? Be careful. Oh, be careful. So what we have is 1 1/8 plus 1 1/4. One of those is Saturday and one is Sunday. And we want to let her do that twice. Okay. So parentheses first with your calculator. Be thankful it does fractions. Type in the 1 1/8 and the 1 1/4. And that's going to give you 2 3/8. If you need to stop the video and do that again, that's fine. Bring down this 2 and multiply it. And that will give you 4 3/4. So on those 2 weekends together, she jogs 4 3/4 miles. So number 7 is D. And remember, this 2 is coming from 2 weekends. The 1 1/8 and 1 1/4 would be a Saturday and a Sunday. And I'm not sure which is which, but it doesn't matter because we're building up. Okay, number 8. Margie jogs more than 1.5 miles on sunny days. So we are looking at more than 1.5. So draw your line if you're looking at this on scrap paper. More than 1.5. So it's here. That's the interval line. And the actual interval is above that line. So let's see what they're wanting me to do with this information. All I've done so far is mark off that interval. And now I'll see what I'm supposed to do with it. There are 6 sunny days in this data set. That is not true. Count your X's. There are only 4 sunny days in that data set. There are 4 sunny days in this data set. That is true. There are 2 sunny days in this data set. That is not true, because we've already said there are 4. Margie jogs a total of 5 1/4 miles on sunny days. Well, we're going to have to do some math here. So I have 2 of the 1 5/8 plus 1 3/4 plus 1 7/8. And I need to do parentheses first. So if you have the Casio, you're in good shape. Just be careful typing this in. Type it slowly. This should give you 3 1/4 plus 1 3/4 plus 1 7/8. Again, the biggest thing on that Casio is just typing carefully. It's much easier for me with decimals, but I don't have the luxury on this one. So I'm typing 2, just type slowly. And I came up with 6, and I believe that's 7/8. Yes. I don't have a calculator that does fractions with me. So I'm having to convert all that to decimals. All right, so Margie jogs 5 1/4. That's not true. Margie jogs 6 7/8. I like that one. Margie jogs 10 1/2 on those days, and that's not true. So the 2 that are true are B and E. B and E for number 8. Okay, number 9. The line plot shows the weight of trail mix in bags at a camping event. And I'm supposed to use this one to answer items 9 through 13. All right. Which bag, sorry, I'm making up stuff. You guys noticed I do that a lot. What would each bag weigh if the trail mix is redistributed equally among all the bags? Redistributed equally is division. So we're going to have to take the total weight and divide it up evenly. So we're going to redistribute the weight. What it's telling me is that some bags have 2 pounds, some bags have 4 pounds. So if you draw a bag at random, you might get the 2 pound and your neighbor might get the 4 pound. That's not really fair if we're doing just a random distribution. So what I need to do, first of all, and I think I'm just going to do it right here, I'm going to calculate the total pounds. So in this first one, we have 2 pounds in 3 bags. So that's going to be 6 pounds. In this one, I have 2 1/2 pounds in 3 bags. Remember, bags are X's, so you count your X's, and that's 7.5 pounds. And then I have one bag that just weighs 3 pounds. And then I have 3 times 3.5. Use your calculator. 10.5. And then I have 4 times 2, which is 8. So I'm going to add up the pounds. Don't lose your 3. So we have 6 plus 7.5 plus 3 plus 10.5 plus 8 equals 35 pounds of trail mix. Divided by how many bags? So we need to count the X's. I've got 6, 7, 8, 9, 10, 11, 12. So divide 35 by 12. We're going to equalize the bags. And that's going to be 2 and 11/12 pounds. When you put that division sign into your Casio, use ABC. If you use division, you'll get a decimal. But use ABC and you'll get that fraction out of there. So if you make all of the bags equal, number 9, your answer would be B, where you get 2 and 11/12 pounds in each bag. Number 10. How many bags, how many X's, weigh more than 3 pounds? So draw your interval line. More than is up here, more than 3, and you just count your X's, and there are 5 of them. No math to do there. You just mark the interval and count the X's. Ben buys all the bags that weigh less than 3 pounds. So how many pounds of trail mix did he buy? All of the bags that weighs less than 3 pounds, that weigh less than 3 pounds. My grammar's getting worse. So we're going to say, okay, here is less than 3 pounds. So the interval is down here. This is what he bought. So he bought 2 pound bags, and he bought 3 of those. So 2 times 3, that's 6. And then he bought 3 of the 2.5 pound bags. That's 7.5. And so you add those two together, and I'm thinking he got 13.5 pounds, which is C for number 11. Number 12. I like this one. This one is one, I'm glad they put one of these in. I'm going to make it small to get it in here, but that's okay. How many bags weigh more than 2 pounds, but less than 4 pounds? This is an interval with a very fixed definition, so be careful here. It's more than 2, but less than 4. Let me check that again. More than 2, but less than 4. So the interval this time is in here. And they want to know how many bags, so you just count the X's in that interval, and there are 7 of them. Number 13. Kate buys all the bags that weigh 3.5 pounds or more. How many pounds of trail mix does Kate buy? So we need to look at, I think I'm going to have to put it right here, guys, over the A. All right, so she buys 3.5 pounds and up. So this time we want to count the 3.5 pounds in the interval. So that's going to be here and here. So it's not how many bags, it's how many pounds. We have to do some work. 3.5 times 3. Use your calculator. I believe that's 10.5. And then 4 times 2 is 8. 10.5 plus 8 is 18.5. So she bought C 18.5 pounds of trail mix. Lots of practice with line plots. These show up a lot on science tests. So you may be taking a test that has nothing to do with math, and there it'll be. So it's good to know how to read these. Okay, I think that's all on line plots. In the next video, we're going to be looking at some geometry, looking at the volume formula. So I will see you soon, and I hope you have a really good day. Bye-bye.